Hi students, welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. So everybody, let me know in the chat box if I'm clearly visible and audible to all of you or not, because today we are going to start with a new chapter, that is electrochemistry. So till now for class 12, we have completed solution chapter in detail, chemical kinetics in detail, and now is the turn of electrochemistry. Right, so in total it will take us 4 lectures to complete it. In the first 4 we are going to talk about the basics, electrode potential, EMF, all of these things. After the second lecture we are going to talk about Nernst equation, right, the application of what we are going to learn today, right. And this first lecture and second lecture are correlated to each other. Second lecture is from where the questions are asked. From this lecture also you can expect one question, that is a standard question. But second lecture that I'm going to take up, that is going to cover, like, maybe most of the questions will come from the second lecture. But second lecture you won't be able to understand if you have not done the first lecture, right? Because here we will understand how to calculate E naught cell, right, in different cases, right? What is reducing, what is oxidizing agent, how to predict, what is the representation of the cell. And in Nernst equation, all these things are used to apply that formula, right? So 1-2 lectures are related to each other. If you talk about the third lecture, we are going to talk about conductance, all of that. And the fourth one will be regarding your batteries, primary, secondary, all the theory-based things, right? Okay. So let us start with the lecture. And for that, yes, very good. Good morning, Ankita. Big, let me just wear my specs because that is very important, guys. Otherwise, I'll feel like a blind person. Okay. So what we are going to do, and what about yesterday's homework? How many of you were there in yesterday's live? And how many of you have done yesterday's homework? Let me know in the chat box. So even if you watch on recorded versions, replay versions, right, do the homework, right? And now also maybe some students are in school, right? They will be watching this on the recorded version. Then students, if you have any doubt, even if you watch in the recorded version, put it in the comment section that this is my doubt, so that I can cater to your doubt in the next class. Obviously, live is better because I can answer your doubts like side by side, right? But if you're like, let's say, watching recorded, you can still ask your doubts, right? Let me see. Very good, very good. Uh, JC has done the homework. JC has done the homework after the class only. And Lalhuru has also done the homework. That's great, right? Okay, yes. So everybody, now let us start with the electrochemistry, right? Now it consists of two names: electrochemistry. Chemistry is all about reactions, right? So that means something related to, electricity. Electrons means electricity, because if electrons will flow, that means electricity. And chemical reaction. And chemical reaction. So the interconversion of chemical reaction to produce electricity, use of electricity to generate a chemical reaction, that is called electrochemistry. Electro means electricity, chemistry means chemical reaction, right? Study of production of electricity from energy released during a spontaneous process. That means if you're preparing electricity from chemical reaction, right? Two processes are there. One is we will generate electricity through a chemical reaction. Second is from the electricity already there, we will actually produce some products. That means there will be some chemical reactions because of the electricity that you have, right? So now two cases are there, right? If you have chemical reaction to electricity, if you are making from chemical reaction to electricity, that means chemical reaction has to be spontaneous, right? If chemical reaction is not spontaneous, means occurring by itself, right? So if chemical reaction is not occurring by itself, then you have to give energy for chemical reaction to occur. Then if you're giving energy for chemical reaction to occur, then why don't you directly produce electricity, right? So that means if you want to have chemical reaction to electricity, this has to be a spontaneous reaction which is occurring by itself, and because of that reaction we are able to produce the electricity. Other thing is from electricity to chemical reaction, right? Here we have in chemistry some chemical reactions which will not occur by itself, right? There are some chemical reaction, students, which are like, hey dude, I am so rigid, I will not occur by myself. You have to provide me energy. That is called a non-spontaneous reaction, which is not occurring by itself, right? So in that case, for a non-spontaneous reaction, you will provide energy in the form of electricity, and that is your non-spontaneous reaction. Understood? Firstly, tell me, is this electricity, electrochemistry definition clear to everybody? What we are going to discuss in today's lecture, is that clear? Good morning, Chandu. So is that clear to everybody or not? And please respond, right? Otherwise, I feel like I'm teaching walls, right? Okay? You are not Chat GPT, you are not AI. Even Chat GPT to responses like anything, right? So you are human. So humans respond. That is our biggest asset, right? That we can emote emotions, right? So you need to respond, you need to interact with me, only then I'll be able to know that whether you like is whether that is clear or not, right everybody? So I am waiting for your answers. It's not gonna happen like that. I'll just end the live stream now only, right? So if you want me to teach, you have to respond, right? I am not asking you to write down paragraphs, right? All I am asking is, if that is clear, whenever I ask you, you have to respond, right? If you can't even do that much, I think that is bare minimum. If someone is asking, your teacher is asking for that thing. Even I don't think so I have to ask for that thing. That is your responsibility. Do you ask me, ma'am, do this chapter? No, right? I do it myself, right? So I try to be as efficient as possible for you guys. Why can't you guys? Right? Okay. So now after this, what we have understood electricity to chemical reaction to electricity. So based on this, we have two kind of processes. One is the electrochemical process, electrochemical cell. Other is electrolytic cell, right? Two kind of cells we have here. So if you talk about electrochemical cell, let's understand that. In electrochemical cell, you have some reaction, spontaneous redox reaction that is already occurring. From that reaction, you are generating the electricity, right? Chemical energy to electrical energy, that means C2E is happening here. From C to E means spontaneous chemical reaction to electrical energy, we are converting it into. If you talk about electrolytic cell, it is exactly the opposite of that. You have electricity, electrical current you have. From that, you are generating a non-spontaneous redox reaction. So, non-spontaneous redox reaction carried out to change electrical energy to chemical energy. That means it is EC, where electrical energy is converted to chemical energy, right? Now, these are the two definition, two cells that we are going to talk about in first lecture and second lecture. Our focus will be entirely on electrochemical cell, but after that we'll start doing electrolytic cell, right? That is different from electrochemical cell. The rules that are applied to electrochemical cell are not applied to electrolytic cell, right? So things are different, right? So that's why you have to work on that, right? Talking about electrochemical cell, just remember this one simple thing here, that is LOAN. Now what is this LOAN, right? For electrochemical cell, you have to remember LOAN. For this, you have to remember LOAP. Now, ma'am, what do you mean by that? Let's understand that, okay? So, there is one difference in electrochemical and electrolytic cell, which is based on the electrodes, right? That's why I'm telling you that. See, if you see, this L means loss of electrons, or I can just write it with white pen here. so that the differentiation is there. This is loss of electron, right? This is oxidation. This is oxidation. This is anode. A for anode. And anode is a negative electrode. Negative electrode. Now, you might feel that, ma'am, why anode is a negative electrode? In discharge tube experiments, ma'am, we have studied electrolytic cells also. In that, anode was positive. But now you are saying anode is negative. So that is the difference, right? Where students usually get really confused, right? So what is the difference? That in case of electrochemical cell, anode is taken as negative. But in case of electrolytic cell or discharge tube experiments, everywhere else, anode is taken as positive electrode, right? Anode is taken as positive electrode. Rest of the thing is same, that loss of electron is oxidation, and oxidation always occurs at anode, right? Oxidation will always occurs at anode, right? Now, how many of you, right? Okay, just I'll start that. Don't worry, we are on that line. Firstly, I just want you to go through the notes that I'll give you, right? Because I have covered NCERT as well. Then once we have completed our syllabus from this, we'll start with the NCERT, right? Now tell me one thing. You have loss of electron, oxidation, anode, negative electrode. Is that clear? Electrochemical cell we are going to discuss. That means when at anode, there will be loss of electrons, and that is called oxidation, right? That is your electrochemical cell, and anode is always going to be a negative electron. For now, you can ignore electrolytic cell. This I just told you so that you can understand the difference, right? You can compare it. Now, understand one thing, that as I told you that we are going to discuss electrochemical cell. So from the title of this video also you can get an idea that we are going to discuss about galvanic cell. We are going to discuss about voltaic cell. We are going to discuss about Daniell cell, right? Trust me, all these are same only. The name is different, right? So majorly we are going to talk about Daniell cell, voltaic cell, galvanic cell. What are these things, right? But before that, you need to tell me if you know what is oxidation and reduction. Yes, students? Tell me, do you have any idea on what is oxidation and what is reduction? See, two things we have. One is oxidation, one is reduction. This you must have studied in redox reactions. I am assuming that you can't recall redox reactions. So if it's like that, ma'am, I can't recall redox reactions. In that case, how you will actually understand this thing, right? So, simple thing you need to understand, that in oxidation there is loss of electrons, right? In reduction there is gain of electron. It is always this, no matter whatever is the cell, right? So always in oxidation there is loss of electron, and reduction there is gain of electron. And in terms of oxidation number, because it is easy to understand this on the basis of oxidation number, right? So on the basis of oxidation number always increases in oxidation, and oxidation number always decreases in reduction. That is a simple case that you will use to identify where oxidation is happening, where reduction is happening, which will act as cathode, which will act as anode. Okay, students, is that clear? Yes, everybody. Now, we will talk about Daniell cell, right? So, talking about Daniell cell, what we have to understand here. See, when you talk about Daniell cell, one thing which is very important for you to learn is what is galvanic cell and voltaic cell, right? So, galvanic cell is a setup where, or you can say voltaic cell, these are the same thing. Galvanic, voltaic is the same thing, right? So, where you have one beaker here, right? Then you are putting an electrode, any electrode you can put in galvanic or voltaic cell. You have an electrode here, you have an electrode here, right? Understood? Now, whenever you have this electrode, let's say you have electrode of X, this is electrode of Y, then the salt will also be of X, right? Salt will also be of Y, right? That is your electrochemical cell. The electrode that you're putting, the salt also has to be of the same thing. The electrode that you're putting, the salt also has to be of, the electrolyte also has to be of same thing, right? So the general thing is called galvanic or voltaic cell, right? No idea what is the electrode we are using. We are using one electrode at anode side, one electrode at cathode side. But if I talk about that, we have here which thing? Zinc electrode and copper electrode, right? So zinc electrode, I am specifying that this is zinc electrode. I am specifying that this is copper electrode. In those cases, when you are specifying this, that only zinc, I am not saying I am specifying this is aluminium. No, that will not be Daniell cell. Daniell cell is when we will use anode as zinc and we will use cathode as copper, and this is one of the most famous cells, right? That's why we are studying it individually here, and that cell is called the Daniell cell. Okay, now we are going to talk about the working of Daniell cell. What does this diagram mean? How we can generate? Can you see this? Here you have voltmeter. From voltmeter you will be able to identify, is there any voltage fluctuation, right? From that you will be able to understand, is there any current flowing here? Are we able to convert our spontaneous reactions into electrical energy or not? That we will talk about in the Daniell cell. But for that you need to understand the working of the Daniell cell, right? To understand the working of the Daniell cell, now one thing always remember, in electrochemical cell everything is AC. Everything is AC. AC, you can't live without AC. Electrochemical cell also can't live without AC. Now what do you mean by AC? Always on the left side you will have anode, on the right side you will have cathode, right? Now ma'am, who will tell us to choose which is anode or cathode? That we will talk about in the later part of this particular lecture, right? For now, just understand the working of the Daniell cell. If you have zinc here, if you have copper here, what are the things that are going to happen, right? So now we know that, anybody in the chat box, at anode what happens and at cathode what happens? Anode what happens? Anode, everybody in the chat box, anode is about oxidation. Oxidation is loss of electron, right? Now see one thing, you have two things here. You have zinc and you have Zn2 positive ions. Who can lose the electron? Who can increase the oxidation state, which is able to lose the electron? If it increases its oxidation state, it is already +2, it will be increased to +3, +4. But zinc +3, +4 is not possible, right? So that means zinc 2 positive is not going to lose, but the zinc is going to lose 2 electrons to become Zn2 positive. Now, ma'am, why only Zn2 positive? Why not Zn positive? Ma'am, why it is not losing 1 electron and becoming Zn positive? Because Zn positive does not exist, right? Zn2 positive exists, and that we will see in DNF block. We will talk about, because zinc is a element of 3D series, right? So we'll talk about why it is based on the electronic configuration. So we'll talk about in DNF block why certain oxidation of metals will not exist, right? So zinc positive does not exist. We have Zn2 positive. So that's why what will happen here, you can write it that zinc is going to lose the electron to become Zn2 positive plus 2 electrons, right? Now zinc is actually this electrode, 1 atom, 2 atom, 3, 4, 100,000. We don't know how many atoms will actually be converted to zinc 2 positive, right? Now zinc 2 positive, let's say this is converted to Zn2 positive plus 2 electron. These 2 electrons, because this is a negative electrode, this is a negative electrode, this is a positive electrode, so it will be moving in this direction. The electrons that are generated after losing 2 electrons, when zinc is losing 2 electrons, right, each atom is losing 2 electrons. We don't know how many atoms are losing 2 electrons. So all the collection of that electrons will move to this side. Okay. And now what about Zn2 positive? Zn2 positive will fall into the solution, right? So here you will have Zn2 positive, right? By this thing, can I say one thing? That let's say if you have Zn2 positive here. Earlier, let's say you had this much thickness of Zn electrode, right? Some atoms are falling into the solution by becoming Zn2 positive and electrons are moving here. That means, can you say 1 atom, 2 atom, 3 atom, 4 atom? This zinc electrode is actually getting thinner and thinner as the reaction is proceeding, right? That means zinc electrode is losing its weight, right? This is a very important thing, that anode will be thinner, right? As the reaction will proceed, anode will lose the weight, right? And ma'am, what about this Zn2 positive? Here we will talk about the charge, okay? So we know that anode is getting thinner, and what about this? What is happening here, right? This is your Zn2 positive. Let's say earlier, let's say you had 100 molecules of ZnSO4. That means you will have 100 Zn2 positive, you will have 100 SO4 2 negative. 100 each you will have, right? Now, let's say here 50 molecules, 50 ions of Zn2 positive will fall into this. Now, how many ions, right? Yes, its thickness will decrease. You can say it is getting thinner. You can say it is losing weight, or you can say its thickness is decreasing. It means the same thing, right? Now tell me one thing. Will the positive charge increase here or not? Anybody in the chat box? Will the positive charge increase here? You have already 100 at 100 ZnSO4, that is 100 Zn2 positive and 100 SO4 2 negative. You already have in the solution. Now, when zinc electrode is losing, right? So what will happen? Some more Zn2 positive ion will fall into it. Yes, very good, very good, very good. So here what you will have, the positive charge will start increasing. So this overall solution will start becoming positive. For this, just remember that this overall solution, two effects will be there after the reaction. Electrode will get thinner and the positive charge over here will start increasing, right? This is happening on the anode side. Now, let's understand what will happen at the cathode side, what is going to happen here, right? To understand that, you have to remember one thing, that what is going to happen at cathode? Is there loss of electron? Is there gain of electron? What exactly happens at cathode side? Yes, everybody in the chat box. Is there loss of electron or is there gain of electron? See, loss of electron was at anode. So cathode is gain of electron. Now, gain of electron, which exactly electron it is gaining? The electron that are produced by this Zn, it is moving here, here, here. Now here this electron is moving, and over here in this solution, you have CO2 positive and SO4 2 negative. So we know that who will gain the electron? This is copper. See, if copper gains the electron, it will become Cu negative or Cu2 negative. Have you ever heard about Cu negative or Cu2 negative? No. This does not exist only, right? So it's not possible for copper to gain the electron. Then who will gain the electron? This CO2 positive ion is going to gain the electron and become copper electrode, and it will start getting deposited on the cathode, right? So now what is happening? At the cathode side, some Cu2 positive ions from the solution are catching these electrons and becoming Cu, that is copper metal, copper atom, and they are getting attached on this particular electrode. Now tell me one thing, is this electron getting the thickness is decreasing or the thickness is increasing? Yes, everybody, is the thickness decreasing or increasing? Students, response, right? I don't know why do I have to tell this basic thing to you guys, right? So is the thickness decreasing or increasing? Thickness will see. I don't. You're not going to reply, so I'll think that you are not there in the class, because whenever I look at the charts, you are blank, like literally blank. I don't know what's the issue with you guys. I seriously don't understand that. A teacher is teaching you with uttermost patience that they can have, but still you have no respect for the teacher. No, even a single bit of respect you don't have. So this electrode here, now I am not going to look at your charts. Never again. So this is your copper electrode here, right? And when copper 2 positive ions are gaining the electron, this is getting deposited on the electrode. So that means the thickness of the cathode is going to increase in this case. So can I just write here that it is here thicker. So you know what, you can write it like this. Here thickness is decreasing, you can write it like this. That will be a better way of writing this. So here you can write thickness of electrode decreases. In this case, thickness is going to increase, right? Now tell me, in the overall solution, is it going to be a positive charge or not? Right, everybody? Is it going to be a positive charge or not? This is your solution. Which charge is going to increase here? Positive charge or negative charge? Yes, everybody? See, if you have here, this is Cu2 positive, this is SO4 2 negative. Let's say I have 100 molecules of CuSO4 here. See, I am just taking random example here. 100 molecules, so definitely it will not have, right? It's billion trillions of molecules it will have, right? So let's say 100 CuSO4 you have. That means you have 100 Cu2 positive and 100 SO4 2 negative. Now, when some Cu2 positive are getting converted to Cu, let's say out of 150 molecules are getting converted, 50 Cu2 positive ions are getting converted to Cu. That means we can say it will be minus of 50 Cu2 positive. Answer will be, you will have 50 Cu2 positive and 100 SO4 2 negative. So in the solution, you have less positive ions, more negative ions. That means, can we say that in this solution, negative charge is going to increase? Negative charge is going to increase. Can we say that? Negative charge is going to increase, right? Okay, Naveen, now I'll see the chart, right? Now I'll see the chart. See, I can't stay angry on you for a longer time. You already know that, right? But don't test my patience, okay? Don't test my patience. So this is your positive charge. This is the negative charge that you have, right? Now tell me if till now you have any problem, because the next target is going to be our salt bridge, right? If till now you have any problem that what is happening on anode side, what is happening on cathode side, you can let me know here how anode thickness is decreasing, how cathode thickness is increasing, and how the positive charge on this particular solution is increasing, the negative charge here is increasing, right? Okay. Now, next thing is going to be salt bridge. Salt bridge. Why we need salt bridge, right? Because the problem is that this is all positive, positive, positive. This is all negative, 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 right? So because of this positive here, because of this negative here, electrical neutrality is not maintained in the solution, right? That's why when there is too much positive charge, there is too much negative charge, eventually the cell will stop working, right? We don't want the cell to stop working, right? So what we will do here, because we don't want the cell to stop working, because we have practical applications of these things. So cell should continue. For that, what is the solution? If there is too much positive, if I start adding some negative here, if there is too much negative, if I start adding some positive here, electrical neutrality will be maintained. Let's say you have extra 50 positive charge here. So you need to add extra 50 negative charge here. If you have 50 negative charge here, you need to add 50 positive charge here, right? Now we know that you can't put charge as it is. You need some electrolyte. You need cations or anions to drop into these solutions so that we can maintain the electrical neutrality. And these negative charges will be from the salt bridge. These positive charges will be from the salt bridge, right? So we are going to use an electrolyte in the salt bridge itself. You will have an electrolyte in the salt bridge itself. Like here, we have taken an example of KCl, right? Now, electrolyte means it should have a positive charge, that is cations, and negative charge, that is anions, right? So, I'll tell you in detail what kind of salt bridge you should take. Let's understand this here. A salt bridge is junction that connects anodic and cathodic compartments, right? So, you have this anodic compartment. This is the cathodic compartment. This compartment and this compartment is connected by the salt bridge, right? Like you have one road here, and in between you have a bridge, right? So that is your simple bridge that you have in highways, right? Here it is a bridge of electrolyte, so that's why it is called salt bridge, right? Now, next is it has electrolytic solution. It maintains the electrical neutrality within the internal circuit. So this is your internal circuit where the electrical neutrality is maintained. Now, it's not like you can pick up any electrolyte of your choice, right? There are some conditions to that. The electrolyte used must follow two conditions here. First condition is electrolyte must be inert and strong. Inert means, for example, I am adding here, this is here in this solution, what you have, Zn2 positive, you have SO42 negative, right? Then you add which thing? Firstly, though, you need to understand which thing will be added here. For that, tell me one thing. This is becoming more positive. This is becoming more negative. Now, to neutralize a cation, you will add anion or cation, right? Salt bridge is not present, ma'am. If salt bridge is not present, then the cell will stop working after some time, right? So that's why we need to have salt bridge. Okay? Yes. Now tell me one thing. If you have positive here, you in the electrolyte you have K positive and Cl negative. To maintain the electrical neutrality, what should be added here? K positive or Cl negative? Cl negative, because if you have positive, to cancel this positive, you should add a anion. And if you have negative, to cancel this negative, you should have a cation. Anion is negative, cation is positive. That's how they will maintain the electrical neutrality. So always remember, on the anodic compartment, anodic side, which anion from the electrolyte will be there in the solution? That is anion will drop. Anion will drop. If you talk about on the cathodic side, which particular thing will be there? That is your cation. That will be there, right? Here you will add cation, here you will add anion, always. Now, let's talk about the conditions. Who will tell me that this is the electrolyte that you can choose, this is the electrolyte that you should not choose, right? So, let's see this here, right? First is electrolyte must be inert and strong, right? the electrolyte that you're adding here, that has to be inert. Inert means it should not react with the solutions, right? So for example, I am, let's say, using KCl here. Here I will add Cl. Now if Cl is reacting with Zn, Cl is reacting with SO4 negative, in that case, SO42 negative, in that case, what will happen? New reactions will take place, right? So that's why it should not react to produce a product, right? That's why it should not be, it should be inert, right? So that's why we are saying that it should be inert and strong electrolyte. Now, why strong electrolyte? Because in strong electrolyte, there is 100% dissociation, right? See, if the electrolyte that you are adding here is not 100% dissociated, how will it fall cation into, sorry, anion into this and cation into this? If you want the cation and anion to separate, then they should dissociate. So more the dissociation, right, more the anions and cations we will have. So that's why we need a strong electrolyte here, right? Okay. Yes, everybody. Don't ask me about the sadness. I have given up on you guys, right? I don't actually, now all I do is I think that I need to just give my 100% to you guys. Now, if you don't want a good quality content, that's not my problem. If teacher is standing here for you guys, right? And if you still don't care to reply, you know, just one student is there who is replying, and one student was there, sorry ma'am, and after that, no reply, right? If you don't care about me like asking you again and you don't care about replying, then even I will, what I'll do, I'll stop like looking at your chats. That's all I can do, right? No, nothing more than that I can do. I know if there is some YouTuber like Triggered Insan and all those people, right? You watch roadies, you go crazy for them, right? Go crazy. They're not helping you to become doctor. You go crazy for them. Hey, reply me. This is all what you do. I know what you actually do, guys, right? So you don't care about the teacher, and that's okay. I know whom I am teaching, then it's okay. So first thing we have done. Second is the cation and anion of the electrolyte must have similar ionic conductivity, ionic mobility. Now, why similar ionic mobility you should have, right? So for similar ionic mobility, what you need to have here is, for example, you have an electrolyte that is K positive and Cl negative, right? If let's say K positive has higher speed than Cl negative, right? Now what will happen if K positive has higher speed, right? K positive will drop, but Cl negative has low speed, only one ion will drop into the solution, right? So in that case, electrical neutrality will not be maintained. This will be electrically neutral before this particular compartment, but we don't want that. Then what will happen? This will be positive, this will be neutral. That is not electrical neutrality. So that's why your speed of both the ions should be same. If I am dropping one Cl negative here, only one K positive should be there. If I am dropping 2, here also it should be 2. If I am dropping 3, here also it should be 3. So it should be like that, right? So that is going to be your case of this one here. That is, if your you have two ions here, the speed of both the ions are going to be same, right? So now commonly used electrolytes are KCl, KNO3. These are commonly used electrolytes which actually follows these conditions. Now, in this salt bridge, if you see, this is the salt bridge that you have here, right? In this salt bridge, right, a U-tube, right? Not a YouTube that we are watching, the YouTube that is over here that we use, right? So U-tube filled with gelification agent. So what is a gelification agent? That makes the electrolyte very viscous, very thick, so that it's not a very increased flow of electrolytes dropping into the solution. So what we do here, we gelify the solution with the electrolyte so that what happens, the speed is same for both electrolyte, that is about the electrolyte, but the speed should be slow also. It's not like continuously thousands of K positive are there in the solution, right? So why we are adding this thing? So I'm giving you one example here. Let's say there is plus 50 positive charge. So you need minus 50 only, right? For that, you would want drop by drop. Let's say 3 first, then 4, then 3, and plus 1, plus 1, plus 1. Like that, you need to have minus 50 charge, right? That means first you will have 1 Cl negative, then again 1 Cl negative, then again 1 Cl, 1 Cl, 1 Cl. That's how you want to cover these 50 plus positive charge, right? But what if there is no gelification agent? It is speeding up, right? Directly you have minus of 100 charge. That means you have directly added 100 Cl negative. Now this solution will become negative. Again, this is not electrically neutral. Your task is to make it electrically neutral. So that's why we want 1 Cl to drop here. We want 1 K positive to drop here, so that when this solution is electrically neutral, we can stop it, right? Otherwise, this is continuously going. So as the positive charge is increasing, same way Cl negative will jump here to make it neutral, so that cell does not stop, right? So that's why we say that you need to have gelification agent, and the gelification agent here we use is agar-agar solution, and inert electrolyte we use here, like KCl, KNO3 is the inert electrolyte that we use, right? Okay, what type of question will come from here? We will see what type of questions, right? I'm going to teach you some previous year questions as well. Don't worry about that, right? Now, next part is direction of flow, right? How does direction, let's say we have NO3 negative will drop into this, because anodic compartment has anion, cathodic compartment has cation, right? Now let's talk about direction of flow of electron. That is over this side. This is where the electrons are flowing. I have told you in the first figure also. Now the direction of current is opposite to electrons, right? So if the electrons are flowing to this side, the current is going to flow in this direction, right? If the electrons are flowing in this direction, the current will be in the opposite direction. This is by convention that we take, right? So if your electrons are flowing here, current is flowing here. So can I generalize this statement here, that always electrons flow from anode to cathode. Electrons flow from anode to cathode. These kind of questions they can ask you, right? What about current? Current will flow from opposite direction always. That is, current always flows from cathode to anode. So it will be cathode to anode. Current always flows from cathode to anode. Right, everybody? Let me know in the chat box if that is clear to you or not. Right? Yes, everyone. So, let's talk about the next thing, that is dividing it into half cells, right? So half cells you must have seen in redox reactions as well. So when you divide it into half cell, this is your oxidation half cell, right? From anode side, when you are dividing, this is oxidation half cell, and this one is reduction half cell. This one is reduction half cell on the cathode side. On oxidation half cell, Zn is losing the electrons, right? And on reduction half cell, the copper 2 positive ions from the solution, right, are gaining the electron to become copper, okay? And that's why the anode is going to get, the thickness is going to decrease, cathode thickness is going to increase. Now, first is deflection. Observations are there. What are the observations after this experiment that were observed? First is deflection of voltmeter. That means there is current in this particular setup, right? Next is Zn2 positive concentration will increase. That's why we will apply salt bridge here, right? And mass of zinc, that means anode is reducing. Then copper 2 positive concentration decreases, right? That's why cathodic compartment was negative, right? And mass of cathode electrode will increase. That's why thickness is increasing, right? Both the half cells are electrically neutral because of the salt bridge. Because of the salt bridge, they are electrically neutral. Okay, yes, everybody. Now, next thing is your, this is the overall reaction that I told you. So, how do you write the overall reaction when you have half cells, right? So, this is the oxidation half cell. This is the reduction half cell. So, what you're going to do, you're going to add these two things here. So, when you add this, on the left side, you have these things, right? On the right side, you have this. So when you actually add this and this will cancel out. You will have Zn solid plus Cu2 positive plus Zn2 positive plus Cu solid, right? This is what you're going to add. You add oxidation half cell, reduction half cell, and this is the overall reaction that you will have. And you know what? In the exams, I'll also show you some questions based on that. So in the exam, what happens? They give you this kind of situation and then they ask you which is oxidation half cell, reduction half cell, like that. Okay, don't worry, we're going to talk about that. Now, we are going to talk about external potential. Okay, so 3 cases are there, and based on these 3 cases, they have asked questions in NEET exam, right? Statement-based questions, theoretical, conceptual questions they have asked based on this particular cases, right? So when you have any external voltage that you are applying, right? Now 3 things can happen. So firstly, ma'am, what is this 1.1 volt, right? You will see this diagram in your NCERT, right? So I'll also teach you how to calculate E0 cell of the overall reaction. For now, keep it on hold. Just remember that the E0 potential of this overall Daniell cell is 1.1, right? Now, if your external potential is greater, less, or equal to 1, according to that, you will have different observations here. So let's say that the external potential is less than 1.1, right? So if you are there, you and your best friend are like chuddy buddies, you're talking to each other, some other person will join you and they will try to, right, break your friendship, right? Now, if the person is very strong, right, then they will be easily able to break. If the person is not so strong, they will not be able to break, right? So here, the external potential is weaker than 1.1. So it will do nothing to this cell. No change in this cell. No change in the cell. It will go as it is. Electrons will flow from anode to cathode. Current will flow from cathode to anode. As it is, it will be. Second case is, if the external potential is equal to 1.1, right? Potential that it was producing is 1.1. Externally, you have potential that is equal to 1.1. If the potential is same, right? This is also giving you 1 slab, this is also giving you 1 slab, then what will happen? The cell is going to stop because it is equal to 1.1. So it is not greater, it is not less, it is equal. So it will not reverse the situation. It will not keep the situation as it is. It will make the cell stop. So the cell will stop in this case, right? It will stop working in this case. Third is, if your external, and this is from where the question was asked, I think in latest years only of NEET, the question was, if your external potential is greater than the potential of the cell, right? Here the potential of the cell is 1.1. If it is greater than the 1.1, external potential is greater. In that case, the cell will be reversed. Okay, the cell will be reversed. Now, by reverse, firstly tell me electrons and current flow they can ask you. Electrons and current flow they can ask you. See, in normal situations, electrons were flowing from anode to cathode. But now it is reverse. So, electrons are flowing from cathode to anode, not anode to cathode. So, it will be cathode to anode, right? Second thing is current. That is always opposite to electrons. In the general case, the current was flowing from cathode to anode. But now, because electrons are flowing to this direction, current will flow in the opposite direction. That is anode to cathode. So, current will flow from anode to cathode. From anode to cathode. Right? And here, this is also called that the cell starts working as electrolytic cell. Now it is no more a electrochemical cell. It will start behaving as a electrolytic cell. Because in electrolytic cell, anode is opposite. Here in electrochemical cell, anode was negative electrode. In electrolytic cell, anode is negative electrode. Anode is positive electrode, right? So in electrolytic cell, things are opposite, right? So because this reaction, this particular thing is getting reversed, so everything will be reversed. Instead of behaving like an electrochemical cell, this will start behaving like an electrolytic cell. Based on this, assertion, reasoning questions can be asked to you. It's very, very important. The points that I have told you, thickness, thinness, then anode, current flow, electron flow, these three cases, based on these, they can ask you assertion, reasoning questions, true and false questions, match the following questions can be asked from these concepts all together, right? Okay. Yes, everybody. Very good, very good, very good. Right? So, now let's understand this. If the salt bridge is removed, the voltage drops to zero, unchanged, increases gradually, increases rapidly. Right? If the salt bridge is removed, one student asked me this question in the chat box. So if the salt bridge is removed completely, right, the cell will stop working and the voltage will drop to zero. So answer will be A is your correct answer. It will not work, right, if you don't have any salt bridge in it, right? Now, guys, the second chunk of this particular lecture, that is electrode potential. Now, tell me in the chat box if you're ready for electrode potential, then spam the chat box with green hearts, fires, because one topic done, right? Now, we are going to talk about electrode potential. And this will be used in your Nernst equation. First thing is, you will ask me when students just cram the formulas, they don't know what exactly is electrode potential. So electrode potential is developed because of one thing, right? So I'll just show you that thing here, why this is developed, okay? So this is your Daniel cell, right? Let's go to the first one, this one only. This is your Daniel cell. Now, can you say one thing? Because this is actually having positive, positive. This is having a negative, 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 negative charge. See, one thing is anode is a negative electrode, right? So that's why this anode will be negative, 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 right? Or you know what I'll do here? You know what I'll do here? I'll copy paste this and I'll copy this particular slide here so that when you are going through the notes, so even then you can understand what is happening here, right? See one thing. What exactly is electrode potential? Why this happens, right? For that, you need to understand that whenever we are talking about anode, this is a negative electron. This is negative, 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 negative. This is a positive electron. Positive, 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 positive. right? That we know anode is a negative electrode, cathode is a positive electrode. Now, because of the internal circuit here, this particular thing, tell me this solution was becoming positive, right? So this solution will become positive. Okay? And this here will become negative. Now, because of this difference in the charges, it will start developing a electrode potential, right? If you go through physics, right, you must have, like, I know physics is your pain point, I know that, right? But you must have gone through capacitors and all these things. Even I don't remember it as such, but there was something like, if you have a positive plate, you have a negative plate, right? So by capacitor, capacitance will start developing. So we are not going to get into that, right? But similarly, you have electrode potential. So if you have difference in the charges, it will start developing a potential difference that is called electrode potential, right? So the potential that you develop on the anode side, this particular potential will be called E oxidation potential. I'll just write it here because oxidation is happening. This is oxidation potential, right? And here what will you have? Here on the reduction side, you will have reduction potential. Reduction potential, right? Reduction potential. There you have oxidation potential and reduction potential, right? That's why what you do here is the potential difference created between electrode and electrolytic solution. This was the electrode, this is the electrolytic solution. The potential that you are developing because of this difference here, that is called electrode potential, right? When concentration of all species, now what is standard electrode potential? Standard is when concentration of all species becomes in the standard condition, that is unity, that means 1 molar solution. If gases, then you're talking about pressure is 1 bar. Concentration or pressure, concentration will be 1 molar, pressure will be 1 bar. If this is the condition, then that electrode potential is actually your standard electrode potential. Simple electrode potential is denoted by E. Standard electrode potential is denoted by E naught, right? This is called naught, E naught, and this is E, right? Understood? This is your E, this is E naught. Now, this is a very, very important point that I'm going to discuss because questions for sure, 1 or 2 questions will be based on Nernst equation. Directly 8 marks will be there. Nernst equation I'm going to talk about in the next lecture. But in the Nernst equation, you have to calculate E naught, and that's where students get stuck. You need to understand representation, how to calculate E naught from there, from reduction, oxidation, what is the relation. All of these things are very, very important for you, right? So let's see this, right? Now, one is oxidation half cell, reduction half cell. Oxidation half cell will give you oxidation potential. This will give you reduction potential. Now, ma'am, on oxidation, ma'am, I have zinc. So what if I calculate zinc oxidation potential? Here I am calculating reduction potential of copper, right? Because copper is on the reduction side. So when you experimentally calculate, you will get the reduction potential of copper. Here you will get the oxidation potential of copper. Because, oxidation potential of zinc, right? Now, ma'am, can I calculate reduction potential of zinc? Can I calculate oxidation potential of copper? Yes. So we have this direct relation, that is oxidation potential is minus of reduction potential. Let's say you have E naught cell of some, let's say Zn. Chalo, one thing also, let's say, okay, E naught potential of zinc, oxidation potential is, let's say, X. Then the E naught zinc reduction potential is going to be minus of X. Okay. Or if I say E naught of copper reduction potential was coming out to be X, then E naught of copper oxidation potential will be minus of X. They are opposite to each other, right? That is clear from this particular equation. Now, next question is how to write oxidation potentials. How to write a reduction potential, right? How to write oxidation potential or reduction potential. And trust me, students feel this very difficult thing. They feel that, okay, ma'am, this is actually the most difficult thing for us. Because based on this, they do silly mistakes in the exams, right? So see this. How to write oxidation potential. If I want to write oxidation potential of zinc, that will be E naught. Zinc is losing the electron. So losing means oxidation number should increase. Oxidation number should increase. So I'll just write it here as well. Here you are discussing oxidation potential, and here we are writing reduction potential. Reduction potential. So how do you write it? If I am writing oxidation potential of zinc, I will write the one that is increase in the oxidation number, that will be Zn2 positive. So it is 0 to +2. This defines the oxidation potential, because in the exam they will not write it like this, E naught Zn oxidation potential. No, nowhere you will see things like that. Okay, this kind of thing is not written. This is how they write it. So how do you understand this is oxidation potential? Because this is 0 to +2, it is increase in oxidation number. Now, similar way, if you want to write the oxidation potential of copper, then it has to be from copper to positive, right? Similarly, you have reduction potential of zinc will be opposite, that is Zn2 positive to Zn. Oxidation number is +2 to 0, it is decreasing. Reduction potential of copper is Cu2 positive to Cu. That's how to write the oxidation potential and reduction potential, right? Now, next thing is, from the experiment, from the Daniell cell, you will have this thing. You can calculate this thing. If this thing is x, you can say this thing is minus of x. If this thing, they will tell you in the experiment, this will be from the experiment. Because in the experiment, copper is undergoing reduction. So you will be able to calculate reduction potential. If this is y, this is going to be minus of y. Okay, right? Tell me if this particular set is clear to you or not, right? Students, if this particular set is clear to you, then let me know in the chat box, right? Now, next is the factors affecting electrode potential. One is nature of metal electrode, right? Then there is concentration of ions in the solution. Then there is temperature. These are the three factors that will affect the electrode potential, right? But today, what we are going to discuss, this we will discuss in the Nernst equation. Because in Nernst equation, we are going to find out the EMF, that is E of cell. Okay? Or you can say not at standard condition. In Nernst equation, we will find where temperature is not standard, where concentration is not fixed, where nature of the metal electrode is definitely fixed, right? Only then we can calculate, right? So these two things are not going to be fixed in the Nernst equation. Today we will talk about E naught. Here we will talk about E, right? So E naught, temperature is fixed, concentration is fixed, right? So that's why we will write it here. What exactly is, one thing, temperature is not fixed in E naught, right? Only concentration is fixed. Okay? But in Nernst equation, we will also see how temperature variation is there, right? So today we are going to talk about E naught cell when the concentration I am fixing. Now, ma'am, you already told about E naught, reduction potential, oxidation potential. but you also need to calculate the E naught of this cell, right? How to calculate E naught of cell? Ma'am, simple formula, ma'am. E naught cathode minus E naught anode, right? How many of you have crammed this formula? But you have no idea how this formula is derived. See, simple derivation, it's not at all a rocket science, right? So, how do you understand what is the E naught cell potential? The potential difference created between two electrodes, cathode and anode. When the potential difference is created between cathode and anode, what is the difference? For example, here it is X, here it is Y, right? Now, what is the difference in the potential difference, right? That is called the cell potential. So, cell potential is difference between electrode potential of cathode and anode. How do you calculate that? So I'm going to talk about E naught of cell. That is equal to which thing? Let me see if you have another page. Yes, right. E naught of cell is equals to, firstly tell me at anode side what you have. Oxidation potential. So I'll write E naught of anode, and at anode you have oxidation potential, plus what you have overall E naught potential will be total, that how much electrode potential you have at anode, how much electrode potential you have at cathode. But at cathode you have reduction potential. Okay, so either you learn this formula, but this so very rare you will use, right? You can learn this formula, it's not a bad thing, right? Why? Because in most of the questions, they will not give you oxidation potential. They will give you reduction potential of everything, right? But you should know this, that it is generated from this thing. Firstly, you add at anode, there is oxidation. At cathode, there is reduction. That's why I have added this. Now, I want to convert it into whole reduction potential. So, I know that oxidation potential is minus of reduction potential. So, can I write it like this? E naught of cathode. This is reduction potential. So answer will be E naught cathode reduction potential minus E naught anode reduction potential. Right? Usually students just cram this particular thing, that it is cathode minus anode. And that's where they go wrong, right? Because you don't need to just cram that this is cathode minus anode. You need to understand that this is cathode reduction potential. This is anode reduction potential. If they give you oxidation potential of both the things, things will be different, right? If I want to calculate the oxidation potential here, I'll write it as E naught cathode oxidation potential. This will be minus plus. So it will become E naught anode oxidation potential minus E naught cathode oxidation potential. If they give you oxidation potential, if they give you oxidation potential of anode, reduction potential of cathode, then you use this formula, or you convert all of them. Another way is just to learn this thing, just to learn this particular formula. This is what I always advise the students. Just learn this particular formula, and what you do for anode, whether oxidation or reduction potential is given, always use reduction potential, right? That I have already told you, that how will you understand whether oxidation potential is given or reduction. If the oxidation number is decreasing, that means reduction potential is given. Let's say they have given you oxidation potential, convert it into reduction potential, right? Then only use this particular formula that you are cramming here, right? Okay, so this is also called right minus left, that I never advise the students. Now, next thing is representation of the cell, right? For the representation of the cell, what you need to understand, right? One thing is, on the left side, you always have A, right side, you always have C. It's always AC, AC, AC. Anode, cathode, anode, cathode, anode, cathode, always. Right? And if you see this double line here that is representing the salt bridge. So you can say this is nothing but this is the salt bridge. Salt bridge. Okay. What about this? Here can you see there is positive to 0. There is a reduction happening in this case. And here can you see there is oxidation happening, 0 to +2 oxidation. So this is your anode side, this is cathode side, and it is always going to be like that. It will never be reduction and oxidation, never. It will always be AC, that is anode, cathode, oxidation, reduction. Always representation is like that. Now, because here the phases are changing, that's why we have one line we have drawn here, right? Here also phase is changing from aqueous to solid, that's why we are drawing one line. Let's say there is no phase change, then you will simply draw comma here. If this is also aqueous, this is also aqueous, then there is no phase change. So when there is no phase change, you will simply draw arrow here, right? But here you have phase change, so that's why you will not draw the arrow but draw the line here, right? Now, if you see this reaction here, firstly, whenever these things are given to you, you need to learn how to convert it into reaction. Okay, so I'll tell you how to do this. This is Cu2 positive, Cu2 positive, and this is Ag to Ag positive, Ag to this is Ag positive to Ag. This is the full reaction. This is the unbalanced reaction. Okay, I'll tell you in the next class how to balance this, right? So this is the reaction that you will have. Now this is A and this is C. And what we draw always, we always write it as E naught of cathode minus anode. Instead of this, I will ask you to write it down as E naught of cathode minus anode. Cathode reduction potential minus anode reduction potential. Cathode is this thing and the reduction potential will be Ag positive to Ag because the oxidation number is decreasing. So it's Ag positive to Ag, right? Anode is this thing and the reduction potential is Cu2 positive to Cu, right? So it is Cu2 positive to Cu. That's why you write it like this. And these values will be given to you in the question. But what they can do is they can give you E Cu2 positive. Then you have to take minus here, then you put it in this value. Then only you will get the correct E naught cell here, right? Okay. I think this also is not needed. Standard hydrogen electrode. Now let's talk about SHE, that is standard hydrogen electrode. So standard hydrogen electrode is a way of comparing things with something that is standard, right? So we take the SHE, that is standard hydrogen electrode, as 0, right? We fix that the E naught of reduction potential, reduction will be decrease in oxidation number. So it will be H positive to H2, that is going to be 0. And E naught of oxidation potential of hydrogen, that is 0 to 1, that is also going to be 0, right? Both the reduction and oxidation potentials are going to be 0 here, right? So the potential, and how, ma'am, it is 0? We are assuming that for hydrogen it is 0. After assuming for hydrogen, we are going to compare it with every other thing so that we generate that reactivity series that you will see in just next slide, right? So potential of individual half cell cannot be measured. We can measure only the difference between two half cells, right? So only comparison we can do. So that's why we are choosing to take the half cell of hydrogen as 0. So this is your hydrogen electrode potential diagram. This is SHE, which is that 1 molar solution of H positive ions. The pressure of H2 is 1 bar, right? Here, because after these bubbles are made, right, all these things happens, and after that we fix that E naught potential of hydrogen. So this SHE we can use as anode or cathode, right? So tell me, when we use this as anode, simple thing you tell me, when you use this particular SHE, for example, this is used as anode, right? Then the other cell here will be cathode. Let's say I am using this as cathode. Let's say I am using this as cathode. This is my cathode. Then the other cell here is going to be anode. So this is a differentiation that you need to understand, that we can use this as anode or cathode. If I am using this as cathode, other thing is going to be anode. If I am using this as anode, other thing is going to be as cathode. Now, if you are using this as cathode, then you are calculating the oxidation potential here of other atom, of other metal, right? Because other metal is on the anode side. If you are using it as anode, then you are calculating the reduction potential of the metal, okay? Then you are calculating the reduction potential of the metal, right? Okay, so it totally depends what you are using, and this is an experimental thing. You don't need to get into so much detail of this, but this theoretical thing they can ask you, if you use hydrogen SHE as anode, statement based question like that can be there. Then if you use this as cathode, the other thing will be anode, and that's why for the other metal, maybe zinc, maybe copper, anything you can use, right? So you are calculating oxidation potential for that particular metal. And here if you're using this as anode, you are calculating reduction potential of that particular metal. Okay, is that clear? Yes, everybody? Yes. What to do, yaar? I can't put in your syllabus Insta reels and shorts, hai na? Movies I can't put in your syllabus. And ask NTA, please, yaar, this is very boring. Huh? Why are you doing this, NTA? Do one thing, na? Ask them what is the latest movie, what is the latest controversy on YouTube, right? Ask them what is the trending short, trending meme that is going on. It's all like boring, NTA. They want to be doctors, so they need to dance on reels, right? They don't need to understand these concepts. Hey, who listens to these concepts? I'll ask NTA, huh? I ask NTA for this, right? I'll see NTA if the kind of exam they have given you in NEET 2025, if the same they will give you in NEET 2026, your life will not be boring. Your life will be super interesting, right? Why? Because those students who have prepared well, they will do well in the exam because they were ready for that thing. Because successful people, they do boring things when they are in that zone, right? So if it is boring, it is good, right? If I start making it like very interesting, I'll start doing memes and Insta reels and all that. Now what will happen? Your study will go floating somewhere, not even floating, actually sinking somewhere, right? Your study will actually, your chemistry will sink, and chemistry is only going to give you marks, right? So so let's see this. Standard hydrogen electrode, this is what I told you, right? That is going to be 0. Standard electrode potential SHE is considered as 0, right? Based on this, we have some questions on your screen. So now is the application part has started. Now we are going to see like what is the application part. Now we are going to see how they are going to ask you the questions in the exam, right? So can you see this thing here? Here you have taken AC. AC. Always remember AC. Representation AC, AC. Can you see this is also taken as, this is taken as Cu2 positive to Cu. This is the reduction potential is given. That means cathode is this here, right? Here it is, this is A, this is C. Here this is cathode, this is anode. They are asking you the EMF of the Daniell cell. Talking about this particular EMF, E naught cell is going to be E naught of cathode. Cathode is this. And what is the reduction potential? It is Cu 2 positive to Cu minus E naught of anode reduction potential. Anode is this thing, and here oxidation number should increase or decrease. Oxidation number should decrease, right? See, that's why we can write the oxidation, that's why we can write the reduction potential. So decrement is here, so it should be Zn2 positive to Zn. So you need to write the reduction potential of both of these things. For that, both of them should behave as cathode somewhere, right? So if I see this here, it is behaving as cathode, it is behaving as cathode. That means these values are the reduction potentials. Okay, so you can just simply put it here. For copper, it is 0.34 minus of 0.76, and the answer is going to be 1.1 volt. That is your Daniel cell electrode potential. Yes, very good, Mano Asinath. Very good, very good. Right? So, very good. Beta, energy sign, you are telling me to give more energy. Now tell me one thing. Are you giving the energy? I think I am. Achha, tell me, let's talk about this thing. You can just say whatever you want to say because you have the chat box. Tell me one thing here, Miss Sign, right? Tell me one thing. You're talking about energy. Is my energy low here? Do you think my energy is low? If my energy is, I would not talk like this is this, this is this, this is this, not low energy. And I don't want to actually answer you, right? Because I know what kind of person you are. You're just there doing nothing and just cribbing about everything, right? But tell me one thing. If you ask me about my energy, I don't know how much energy I am giving you. Tell me one thing. What kind of energy you are giving, right? It's been 1 hour. I have not even seen a single message from your side, and you are talking about energy. It's very easy to say whatever you want to say. You are in the chat box, but when you're in front of me, you won't even have a single word to talk, right? You are not that Sai. I'm not talking about you. I'm talking about that one with orange TP, right? So it's very easy to say, ma'am, energy is very low, ma'am. But ma'am, when I ask you, ma'am, we are so lazy to type, ma'am. You can't even say hello, hi, good evening, good morning, answer homework, nothing you can do. From 1.5 hour, I'm speaking. And when I ask you, I have not even seen your text for a single time. Then these people are talking about energies and all that. Stupid people. So, let's talk about electrochemical energy, electrochemical series, right? So when you compare everything with hydrogen electrode potential, that is zero. Whether you compare, whether this is cathode, then this will be anode. Whether this is anode, then this is going to be cathode, right? So when you compare this, you have series, right? You have different metals. You calculate the reduction potential, and this particular series is called activity series, where you have set of, oh my god, I just saw lizard. Okay. So here we have, after comparing with all the metals, right, we are talking about the reduction potential of these metals here, right? The reduction potential of every single metal we have written here. Ma'am, the question is, ma'am, do I need to remember all of this or not? Do you need to cram this? No. You don't need to cram any of this. Just remember the first and the last one here. That is important for you. Other things will be given to you in the question. Nobody is asking you to cram all of this, right? So that is a sigh of relief, right? So now let's talk about this thing here, F2 and Li positive. Why this is so important? See, for this you need to understand this one factor here, that is, what is a reductant? Okay, tell me. If someone, this concept is very important. If someone is getting reduced, if I am getting reduced, I am gaining the electron, then I would want someone to lose the electron and give me the electron so that I can gain the electron. It means if someone is getting reduced, they want to oxidize someone, right? That means they are a very good oxidizing agent, right? So I am a teacher because I am teaching, right? So that's why I am a teacher. I am teaching you guys. So if someone is oxidizing agent, it is oxidizing someone. Someone is getting oxidized here, right? So here we have all the reduction potentials. If I say reduction potential means what is the power of it getting reduced? If reduction potential of this Diksha is high, so I want to get reduced. I want to oxidize someone. That means I'll have a very good oxidizing, I'm a very good oxidizing agent. So you can say this here, that positive standard reduction potential means good oxidizing agent. If someone is very high oxidizing potential, they want to get reduced, they want to oxidize someone, they are a very good oxidizing agent. And if you have a negative standard reduction potential, then you don't want to get reduced. You don't want to oxidize someone. You don't want to oxidize someone means you are a very poor oxidizing agent. That means you are a very good reducing agent. So that is going to be reducing agent, right? And based on this also, you will see in your exam, there are questions in your NEET examination especially, and as well as other exams, what they ask you. This is reduction potential, reduction potential. More the reduction potential, more is the capability of getting reduced, and more is the capability of getting someone oxidized. That means it's a very good oxidizing agent. Oxidizing agent. So more is the value of reduction potential, more is the oxidizing nature, better is the oxidizing agent, right? Or you can say oxidizing power is very good, right? Then if oxidizing power is good, reducing power will be bad. Reducing agent, it will be a bad reducing agent, or reducing power will be bad. Okay? It will be a bad reducing agent and the reducing power will be bad. Achha, what about this reduction potential? If the reduction potential is very high, because oxidation potential is opposite of that, so oxidation potential is going to be very low. And this, students, is a very, very important block, right? Please mark it. Most important thing from where right now they are asking the questions. You pick out NEET 2024, NEET 2025, JEE questions you pick out, AIPMT latest pattern I am telling you, latest questions, right? Earlier from electrochemistry, they only used to ask questions from Nernst equation, but now the trend is beyond Nernst equation. Now these kind of conceptual questions are also asked. Right? Very good, Sai. Very good, Asinath. Very good Vansh. So this is a very, very important thing. Right? Now, here, let's talk about this thing. This has a highest reduction potential. This has lowest reduction potential. Here, why these are reduction potential? Because it is gaining the electron. So these are defining the reduction potential. This has highest reduction potential. This has lowest reduction potential. If reduction potential is highest, that means it is a very strong oxidizing agent because that is directly proportional, right? If reduction potential is low, it is a very bad oxidizing agent. It is a very good reducing agent. If this is low, this is going to be high. That means it is a very good reducing agent, or it has a very good reducing power. Is that clear, everybody? Oxidizing potential. No, Asina, that is inversely proportional. If this is X, this is going to be minus X. Okay? If reduction potential is X, oxidation potential is going to be minus of X. So they are inversely proportional. Okay? Yes? This data, if reduction potential is high, oxidation potential is going to be low. Right? How oxidizing potential will be directly proportional to reducing potential. Yes, oxidizing potential will be directly, I am not saying oxidize, they are inversely proportional. Yes, Sai, you are asking or you are telling? First, you tell me that thing. Reduction and oxidation potential will be inversely proportional. More is the reduction potential, more is the oxidizing power or oxidizing agent, right? More is the reduction potential, less is the reducing power or reducing potential, reducing agent, right? Okay, right, everybody? Yes, that is clear. Okay, chalo. Now let's talk about, okay, you want to discuss this? See, this is minus 3.05, reducing potential. Oxidizing potential will be 3.05, right? So if reducing potential is minimum, oxidizing potential is going to be maximum, right? Here, if high reducing potential it is, so it is going to be minus 2.87. That is going to be the lowest oxidizing potential. So that's why they are inversely proportional to each other. Okay, yes. Sure. Now, next is this, we have already learned that calculation of standard EMF you can calculate from the electrochemical series. First thing is, from electrochemical series you can tell that which is a good oxidizing potential, a good oxidizing agent, bad oxidizing agent, reducing agent, that you can tell. Second is, you can tell E naught cell of the overall cell, right? This we will do. Next is feasibility of the reaction. So if you remember thermodynamics, right? Do you remember thermodynamics, guys? Ma'am, abhi kahan? Thermodynamics, ma'am, we don't remember, ma'am. Thermodynamics, ma'am, it's been a long time. So how many of your droppers, right? Droppers must start doing their revision of class 11th as well, right? Because usually we tend to forget things. That is very normal, right? So we are humans, we will always, we need to keep revising, right? So in thermodynamics, you must have heard about a term that is delta G, which is Gibbs free enthalpy. Okay, Gibbs free enthalpy. Now, this Gibbs free enthalpy is actually the work done, useful work done that we have studied in thermodynamics. For you, one thing matters here, that in Gibbs free enthalpy, you have two things, right? So these two things are, I don't like the notes, I'll just delete this. Just remember Gibbs free enthalpy, okay? That is delta G. It can be positive, it can be negative. If it is positive or negative, what it will define? If delta G is positive, it is a non-spontaneous reaction, right? If delta G is negative, it is a spontaneous reaction. Spontaneous reaction is which is feasible, which can occur. Non-spontaneous is which is not feasible, right? So we can say here, because delta G is equals to minus NF E naught cell, and based on this we will do questions in the next class. This is a very important formula, and trust me, a good level of questions are asked based on this formula, right? That I'll discuss in the next class, right? Now see the conceptual part of it, right? So this is E naught cell. If I am saying E naught cell, right, and this is delta G, and this is reaction, is feasible or not, right? So you have three things: E naught cell, delta G, you need to tell if it is feasible or not. If E naught cell is positive, if you calculate the E naught cell and the value is coming out to be positive, this will be negative because it is minus of that. It is a spontaneous reaction, that means it is a feasible reaction. If E naught is negative, delta G will be positive. If this is negative, this will be positive. It is a non-spontaneous process. Okay, then it is going to be a non-spontaneous process. Let me see, is there any blurriness? Okay, so this is going to be a non-spontaneous process. That means from this you can also calculate whether the reaction is going to be feasible or not, right? Okay, wait a minute, guys, just give me a second. Wait, just give me a second, there's some important call here. Just give me a second. just Amazon delivery things, right? Okay, so now you have this particular thing. Don't worry, you'll be like, ma'am is so happy after getting the parcel. I'm returning the parcel here, not getting any parcel, right? So here it is, E naught delta G, whether the reaction will be spontaneous or non-spontaneous, that you have to tell here, right? Okay, very good, Sai, very good, Sai. If delta G is 0, that I'll write here, that we'll talk about in the next class, right? If delta G is 0, the reaction is at equilibrium. That we'll talk about in the next class, right? Now, let's do some questions based on this as well. So, the first question is the 2023 question, that is, the correct value of cell potential in volt for a reaction that occurs when following two cells are connected, right? So, they are saying you have to actually calculate the E naught cell here. So, for that, what you will do here, E naught cell is, ma'am, when these two things are connected. Now, this is also gaining the electron, this is also gaining the electron. Now here the question is, which will behave as cathode, which will behave as anode? That is the main question, okay? NEET 2023 question, this is which will behave as cathode, which will behave as anode. For that, the one which has high reduction potential will behave as cathode. Now, both of them are reduction potential. This is also reduction potential. This is also reduction potential because it is gaining the electron. So, that's why the one which is high, this one is positive, this is high. So, this will behave as cathode and this is going to behave as anode, right? Now, we are going to write the reduction potential of both. So, we can write here that E naught reduction potential of this cathode, that is 1.33 minus E naught of reduction potential of anode, that is minus of 0.44, and here you will get the answer as 1.33 plus 0.44 and you will get your answer as 44567. No, it will be 4567, 1.77. Okay, that is going to be your answer here, right? Very good, Mano, very good, Ravi. Good, good. So, let's see the next one here. Next is NEET 2022 question here, right? We were ignoring this, but that comes out to be a good topic. They're asking question on that, right? So, this is E naught of cobalt. This is E naught of aluminium. They're asking you standard EMF you have to calculate, right? So that will be E naught of cathode minus anode. For that, you need to understand which is cathode, which is anode. So this is also reduction potential. This is also reduction potential. So can I say here also, see one thing very, very important here. Now they have done like a little thing that will make you get this answer wrong, right? You can easily do a blunder in this question. Let's see how. This is reduction. This is also, they are saying reduction. But can you see one thing? Here, they are saying CO2 positive to CO2 positive to 3 positive. Now, oxidation number is increasing in this case. Can you see, just to confuse you in NEET 2022, what they have done? They have written here reaction. A student who is in hurry, what he will do? He will like, gain of electron, this is the reduction potential. No. This is actually the oxidation potential. Reduction potential is going to be 1.81, right? This is a very important thing, how they can confuse you. In reaction, they are giving something else. Here, they are giving something else, just to confuse you here, right? What about this one? This is gain of electron, but see this. Is this increasing? Ma'am, this is also increasing. This is also increasing, 0 to 3. This also here they have given gain. See how smartly they have played with the emotions of students, right? Now after this, and trust me, all the students sitting in the NEET exam who have done even a bit of practice of electrochemistry, they know this concept. But in hurry, they did mistake here, right? So here it will be This is also oxidation potential. Here reduction potential will be minus or 1.66. Now, which is behaving as cathode? This has more reduction potential, though this will behave as cathode, and this has less reduction potential, this will behave as anode, right? So it is cathode reduction potential minus of anode reduction potential. So answer is going to be, this is your correct answer here. Okay, so it is going to be 7, 8 plus 6 is 14, right? Then 2, 2, 3, 3.47. I hope so I have done the calculations right. Okay, is that clear? Yes, everybody? We have to reverse the sign. So it is cathode minus anode. Now one more mistake you have done, right? You have done this minus this, because this is also minus. This is already minus, right? So you will do this minus of this. Anode, cathode minus anode. Anode is this, cathode is this, so they will add up, right? And this will be your answer in the end. Let's see the next question here, that is, deduce from the following E0 values the half cell. With what combination of two half cells would result in cell with largest potential? Cell which will have the largest potential, students. So let's see this, let's identify this. The cell with the largest potential, right? So firstly, you have to see whether they have given reduction potential or oxidation potential for all of them. The combination of two half cells would result in cell with largest potential. It's a very interesting one. That means that difference has to be largest. So first you have to write down the reduction potential of all of them. This is the, nothing is given here. That means this is corresponding to this reaction. So this is losing. So reduction potential will be equals to minus 1.5. This is reduction potential only. This is reduction potential. Here reduction potential will be 1.5. Now, if you want to make E0 cell, this is E0 of cathode minus E0 of anode reduction potential. So, cathode has to be maximum, anode has to be minimum. Which cathode is maximum? Which cathode has maximum reduction potential? This has maximum reduction potential. So that means it can behave as, see, simple thing is, cathode would want to have, cathode, if you want to make this largest, if you want to make the difference here largest, then this has to be large, this has to be small, right? Only then the difference will be largest. So cathode has to be largest, that means this can be cathode. Anode has to be smallest, right? So smallest value is this one, that is 0.5, isn't it? Because you want to subtract. Now some students will say that, ma'am, isn't this the smallest value? See, if I put this here, this will be 2.1 minus of minus 1.5, this will add up. Then this can be the value. Yes. If you see this here, this is the smallest value here, right? So this will behave as anode. Then cathode minus anode will be 2.1 minus of minus 1.5. This will come out to be 2.1 plus 1.5, that is 3.6, which is the largest value here. So what you will use here, you will use first and second. So answer will be B is the correct answer, right? 1 and 2 we are using as cathode and anode. So answer will be B is going to be the correct answer here. Okay, right, everybody? Why we are selecting 1 and 2 here? Because cathode has to be largest and anode has to be smallest, the reduction potential, only then the difference will be largest here, right? Now let's next talk about NEET 2022 question, that is, at 298 Kelvin, the standard electrode potential, this is. Now, this is also one of the questions that they ask, right? E0 potential, they will give you. Can you see any reaction where you have to remember E0 potential? No. You have to apply the formula, apply the concept. That is needed. You don't have to cram these values, and that's the best thing about this. So standard electrode potential is this. If you see, this is also oxidation number decreasing, 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 decreasing. That means all are reduction potentials. Okay. On the basis of standard electrode potential, predict whether the reaction, predict which of the following reaction cannot occur. These are the options given to you. See, for the reaction to occur, the reduction potential. See, if I want Ag to get converted to Ag positive, that means, I'm just taking one example here. If I want Ag to get converted to Ag positive, that means Ag has to have a good oxidation potential. Because here 0 to 1 means oxidation number is increasing. So it needs to have a very good oxidation potential. If its oxidation potential is good, right? If its oxidation potential is good, that means then it can easily oxidize here. That means, can I say that if zinc I want to convert here, then its oxidation potential has to be more. Here, its oxidation potential has to be more, right? And if you want to convert Cu2 positive, and let's talk about in the form of reduction potential, because they have provided us reduction potential, right? If you want to convert Cu to Cu0, that means you want to convert Cu plus 1 to 0. This is the reduction. So reduction potential has to be more, right? So can I say, in this case, let's say in this case, I'm taking random case here. In Cu2 positive, this is Cu2 positive. To Cu, this is Ag to Ag positive. If I want this reaction to happen, this need to have high reduction potential, and this needs to have low reduction potential. Because low reduction potential means high oxidation potential, that means this will occur. Firstly, tell me if this particular situation is clear to all of you or not. If this particular situation is clear, right? Similarly, here, this should have reduction potential should be less. Here, reduction potential should be more. Here, reduction potential should be more. This should be less. Similarly, here, reduction potential should be more. Reduction potential should be less. Here also, reduction potential should be less. Reduction potential should be more. Now, this is what I am looking for here, right? So, this is what I am looking for here. Now, let's look at this thing, right? Now, reduction potential, let's see what all are given to us. This is for Cu, this is for Zn, this is for Fe, and this is for Ag. So, Ag reduction potential is lower than Cu. So, let's talk about copper and zinc. Copper has to have more. Copper is more than zinc. That means this is possible. Copper and iron. Copper is definitely more than iron. That means this is also possible. Iron is more than zinc. Iron, is it more than zinc? Zinc is this. See, if you don't understand this, so it will be minus of this will be 0.76 in the number line. Negative, large negative value will be on this side. And this will be on this side, right? Only then you will go to 0, then it is 1, then it is 2 now. So this you can make it on number line, right? So definitely this is for iron. Iron is greater than zinc, that is for sure, right? Iron has to be greater than zinc, that is true. Last is copper has to be more than silver. Copper is 0.34, this is 0.80, this is definitely not more, it is less. Because copper is less than Ag, so that is the reason this reaction will not occur here. And the answer is going to be D is the correct answer here. Is that clear, everybody? How D is coming out to be the correct answer? Oh. Yes. Okay, the question is split it. Okay, I'll take care of that. Actually, I didn't have space here. I thought of, I'll take care of that thing, right? Chal. Next is this thing, that is NEET 2023 question, E0 values This and this are given to you. Identify the incorrect statement that you have to identify in this case, right? So E naught values, right, that are given to you, right? You need to identify the incorrect statement. So need to just see true and false here. EL is more electropositive than TL. EL is more electropositive than TL. Electropositive means EL wants to lose electron, right? Electropositive means the tendency to lose electron. This is your NEET 2023 question, right? So EL is more electropositive. EL will be like, I am electropositive, I want to lose the electron, right? So for that, oxidation potential of EL should be high than TL. Only then this is possible. If EL has high oxidation potential than TL, only then this is possible that this is more electropositive. This means tendency to lose electron is more. This means electropositive nature is more. Is it here? Yes. This is the reduction potential. Oxidation potential will be 0.55. Here oxidation potential will be this. Wait a minute. This will be plus 1.66. This is decreasing, this is also decreasing, this is also decreasing. So we need to see the oxidation potential, right? Oxidation potential is minus 1.26. This is 0.34. So if you see this here, aluminium, this TL, they all exist in 3 positive states here, right? So I can say from a larger picture here that this is greater from 3 positive to Al. It is definitely going to lose the electron because oxidation potential is more here, this is less. So I can say this is actually the correct answer here. This is actually the correct statement because see, oxidation potential is 1.6. Why I'm not looking into this thing? Because that is a Al positive is defining less loss of electron. Here the loss of electron is more, that is 3. Here it is minus of 1.26. So oxidation potential is high here, that means it is more electropositive, that is true, right? Then TL3 positive is a better reducing agent than TL positive. TL3 positive is this thing, right? Reducing agent than TL positive. For reducing agent, so I'm talking about better reducing agent, that means it has to have less reduction potential. So that means this should have less reduction potential and this should have more reduction potential, but actually that's not there. This has less reduction potential, this has more. That means TL positive is a better, good reducing agent than TL3 positive. So this is our incorrect statement. This is the incorrect statement. So this is the correct answer. Next is Al positive is unstable in solution. Yes, that's why it is so unstable. It wants to, right? Its reduction potential is very high. It wants to gain the electron because it is not at all stable here, right? And then TL can be easily oxidized to TL and TL3 positive. See, if you see this TL to this particular situation, it will be minus 1.26. TL in this situation is going to be positive of 3.4, right? That means its oxidation oxidize now. So that means to convert here, its oxidation potential has to be good, right? Which we can see, and moreover, you know, if you see TL in positive and TL3 positive state. I'll just show you this from inorganic chemistry point as well, because this answer we can't tell only on the basis of reduction potential. This is actually a statement of inorganic chemistry. Okay? This you will see in block chemistry. Can you see earlier in JE they used to do this, that inorganic and like, you know, physical chemistry together. Right now they are doing this here as well. Right? So inorganic chemistry, can you see that? It's BALGAINTL. It's group number 13. Group number 13 has NS2NP3 electronic configuration. No. Group number 13 has Ns to Np1 electronic configuration. Lower oxidation state is +1, right? Higher oxidation state is +3. So that's why it can easily, because lower and higher oxidation state, it exists here. That's why it can easily get oxidized to these two things. So that's why it is a true statement. From here, you won't be able to answer this, but from inorganic chemistry, it will be more clear to you, right? Okay. Which chapter of inorganic chemistry? This is periodic table. Like periodic classification also we study, P block also we study that, right? Okay. So this is the incorrect one. Next is, will Fe be oxidized to Fe4 positive by the reaction this? They are saying, will Fe be oxidized to Fe what? 4 positive or 3 positive? I think it's 4 positive. No, it should be then 2 positive. Okay. Will Fe be oxidized to Fe2 positive by the reaction with this? See, for the oxidation, if we talk about this, oxidation means from this to this, 0 to +2, when oxidation number is increasing, right? It is 0.44 volt, right? Which is actually not a very, very high oxidation state. So we can say in that case, it will not want to oxidize in there, and they are comparing this with HCl, right? Which has 0 E0. If you say this is oxidation, or hydrogen, the reduction potential is going to be 0. Here, the reduction potential is going to be minus of 0.4, right? Okay, so I'm just gonna define that for you. Here it is Fe to Fe2 positive, right? Which is undergoing oxidation, right? And hydrogen is here acting as a reduction. This is happening at cathode. Okay? So this is happening at cathode. So that means hydrogen is gain of electrons. So it will be H positive, right? And this will be H2, right? So that means, can I say hydrogen reduction potential? That means H positive to H2, it is 0. Reduction potential of Fe, Fe2 positive, no, Fe not 2 positive, Fe reduction potential, yes, Fe2 positive to Fe is going to be, if Fe to Fe2 positive is plus 44, plus 0.44, then it is minus 0.44, right? Because oxidation and reduction are opposite to each other. Now you put it here, E naught of cell is going to be E naught of anode. Anode is what? Which of the following is anode, guys? Which is anode? Which is acting as anode? This is acting as anode, right? So cathode minus anode. This will be, cathode is 0. Anode is this thing. This is acting as anode, right? So this will be minus 0.44. Can you see the answer is going to be 0.44? Isn't it a positive value? If E naught cell is positive, now tell me, whenever they ask you, will this reaction occur, you talk about delta G. So delta G is going to be negative, right? That means this reaction is going to occur, right? That means this reaction is going to occur because delta G is negative. It's a spontaneous reaction. Okay? Understood? Right? And I think so. Let's see how many questions. 1, 2, yes, 2 more questions and we are done with the class, right? So next is AI PMT 2011 question, that is, a solution contains 3 things, 3 ions. The solution was treated with iodine at 35 degrees Celsius, not important. E naught they have given you for this one. First, you need to check whether this is oxidation or reduction potential. See, this oxidation number is decreasing, so this is reduction potential. Okay. Here also 0 to -1. Oxidation number is decreasing, 0 to -1. So it is also reduction potential. Right? Now they are saying the favorable redox reaction will be what? So at this point, you have to see that which will act as cathode or anode. because this is actually your more reduction potential, right? So that's why this will start acting as cathode, okay? And this will start acting as anode, right? Cathode means Fe, the reaction will be, Fe will undergo reduction, that means Fe3 positive to Fe. Now, from these values, you are generating a reaction. Yeah, you're generating a reaction here. This will be iron. Iron is reducing. This is less reduction potential, means it is anode. So here it is getting converted to I negative to I2 because oxidation number has to increase. This is the overall thing. We know that this is undergoing reduction. This is undergoing oxidation. So I2 will be reduced to I negative? No. I2 will be reduced to I negative? No. Right? They're saying favorable. This will not happen here. Right? I negative is getting oxidized to I2. Right? There will be no redox reaction. Not at all. This is also not true. I negative will be oxidized. Yes. I negative is getting oxidized. And Fe will be oxidized. No. Fe3 positive is reduced to Fe2 positive. So answer is C is the correct answer here. So answer is C is the correct answer here. From the electrode potential, you are generating a reaction. Okay. Next is last question of today. Now, this is a very, very important, and this is actually a question that I won't say a very normal one, because if you don't know this fact, you won't be able to answer this, right? So these kind of questions they ask in JEE, right? But you never know they start asking these questions in NEET as well. So that's why I have picked up this question, right? So it is the spin only magnetic movement you have to calculate, right? Of M3 positive ion, right? From the pairs, you have one pair this, second pair is this, third pair is this, fourth pair is this. That has negative standard electrode potential, right? So out of this, you need to understand which has negative standard electrode potential, right? That you will see in DNF block. Okay, so similar, inorganic fused with physical chemistry, right? So this you will study in DNF block, because this is your 3D series. Every detail regarding electronic configuration, how you will find that, all of that you will study in DNF block. For now, I'll just tell you that this is actually the one which has negative electrode potential, right? And standard electrode potential, whenever they say standard electrode potential, don't get confused. It is general term for reduction potential. If nothing is mentioned, whether it's standard reduction or standard oxidation, then take it as reduction potential. Okay. So they're asking about reduction potential, that is negative for chromium, right? So that means you have to define for chromium 3 positive, what is the number of unpaired electron. We know that chromium is 24. Now here you should know the electronic configuration. This is 1s2, 2s2, right? See this particular thing here, right? One is, or you can just say directly argon 18, 4s2, 3d5, and it will be 4s1, 3d5. Okay. After losing 3 electrons, it will become 3d, 3 electrons, na? 3d3. So we can say it will have 3 unpaired electrons, right? So it will become 3 unpaired electrons. So mu is equals to under root n plus 1, or you can just directly say 3.9, because unpaired electron. This also I'll tell you in the DNF block. We are going to again repeat this question in DNF block. I just told you how this particular concept of electrode potential, there is a proper paragraph in your NCERT in DNF block that we will study for DNF block, right? Electrode potential for 3D elements. There also the same concept of standard reduction, oxidation potential, all this will be applied. Now guys, you have this now, this you can easily solve this. 3.9 I told you, approximately 4 it is, so answer will be 4. And the formula is under root n plus 2. That formula and trick, everything I'll tell you there, right? Now this is your homework. First question is zinc can be coated to iron, produce galvanized, but reverse is not possible. What is the reason behind that? So mark it your question number 1 and I'll see that how many of you actually do your homework. Right? Okay. So all the students who are there answering, I'm just going to end this live here. And after that, because I know if you think that after 1 hour I'll do that, that 1 hour will never come. Right? So rather, just now only give your homework. This is the first question. This is the second one. The standard oxidation potential is equals to minus of oxidation, minus of standard electrode potential, minus of SHE, or none of these. So this is your second question, okay, for your homework. And this is like my feelings for you. Like this is how I sit when you don't do your homework, right? And the DPPs are also will be updated. Now I have told the team to update the DPP of solution chapter in the description box. Once you do the DPP of solution chapter, I'm giving you 4-5 days, then I'll give you the DPP of chemical kinetics. Then by that time, electrochemistry also will be over. Then you have 3 DPPs to cover: solution, electrochemistry, and chemical kinetics. So let's do one by one. Firstly, do DPP of solution chapter. And students, this is the description box where you will see the DPPs, the session PDF, everything you will see in the description box here. And here you will also see DNA 2026 batch, where my class is going to be after 1 hour, right? So my class is there in DNA batch at 2:30 p.m., right? We are going to solve structure of atom tattva questions, right? So what we do is, firstly, there is lectures in the class, right? And it's not like in one lecture, 2 lecture, we complete one chapter in like sufficient time, the time that is needed, right? Let's say 10 to 12 lectures for structure of atoms, so that in detail we do that. Schedule will be already provided to you in the batch, right? And the entry point is 21st, right? So I'll just show you here, right? The batch start date is 21st July 2025, right? So just few days, right? And I want to see you in the next week. Now what we are providing: live classes, doubt solving in the classes, quizzes, leaderboards. And after that, you can see your competition in the class as well, where you lie in the leaderboard, so you can improve yourself. After 15 days, we also take your mock test that we are taking from the regular basis. Now, in the mock test, right, the questions you can ask me on the Telegram channel, or also conduct special sessions so that you can ask your doubts, right? Then students, in the next, what we have is test series, right? Test series will be provided to you, right? On your pace also. This is apart from mock test, right? Tattva modules are provided to you. These tattva modules, someday I'll also show you what exactly are these tattva modules. You're totally going to love it, right? Then guys, these are the 3 type of batches. Whatever I told you is here in this particular batch. Then if you want QR cards like this, right? If you want QR cards like this, short revision cards, then you will get for 5,999. And if you want Prime plus NEET QR cards plus All India Test Series delivered at your home, here also it will be delivered, but here All India Test Series also will be delivered. That is at 6,999 for you, right? So now I would love to see you in the batch on 21st of July, right? And I think that's it for today. Now, what's your thing to do? Solution DPP, enroll yourself to the batch, and third is do your homework in the comment section, right? Okay. Okay then students, bye-bye. And don't forget to hit the like button, like this video, right? You don't even like, you don't comment, no appreciation for your teacher. So much efforts we put in for you, but you never care for that, right? So if you're watching on the recorded version, put up a comment. One student in the last batch, he cracked like NEET with a very good score. Then he said to me in a live class on my Telegram, right? Not a class, but is a live chat on a Telegram. He said very proudly, "Ma'am, I totally love your classes. I understand everything, but I have never commented on your video." Then one question that I wanted to ask him was, you're appreciating me, right? In your head, you're not speaking to me, you're not talking to me through comments, then how will I get to know? How will I get motivated? Just imagine you have done good in your NEET exam, but you don't get any seat. You have cracked the cutoff, but you don't get any NEET seat. You scored 650, 670 plus marks, but you don't get any NEET seat, right? How you will feel, right? So when we put in efforts, if you like that, then do comment. Otherwise, when there is no comment, we feel that, okay, you don't care and you don't like this video. right? So our motivation also drops. So that's a factor that plays a major role in our energy, in our content, right? Okay, chalo. Okay then students, bye bye, take care, see you all in the next class. Bye bye.